So in this problem, we are provided with a equation of a parabola. So using this equation, we need to determine the coordinates of its vertex and the focus, the equation of its axis and directrix, as well as the length of the lattice rectum. Let us begin. So here, we'll start with the given equation of the parabola. So here we have x squared minus 2x plus 3 equals to y. So what we'll do, we're going to transpose 3 to the right hand side to get y minus 3. Now x squared minus 2x, we can convert it to a perfect square. All we have to do is multiply with 1 and subtract with 1. So this will be equals to y minus 3. So y squared minus 2x plus 1, this will become x minus 1 whole squared. And we're going to transpose this one to the right hand side. So we get 1 minus 3, that will be negative 2. So we have y minus 2. Now what we'll do, we'll take this equation and then suppose that x minus 1 equals to x in uppercase and y minus 2 will be replaced with y in uppercase. Then equation number 1 is going to transform to x squared equals to y. Now this particular equation can be compared with the standard equation of a parabola, which is x squared equals to 4 times ay. Now when we do the comparison, then the value of a comes out to be equals to 1 over 4. We're going to use this value. So here we have the graph of the parabola x squared equals to 4ay. This is an upward facing parabola. And whenever we have the equation of the parabola expressed in its standard form, its vertex is always going to be at the origin 0, 0. Now the point F, this is going to be the focus having the coordinates 0, a, and the equation of the directrix line will be y equals to negative a. Then the y-axis will be the axis of symmetry of the parabola, and we know the equation of the y-axis will be x equals to 0. And then here we have the lattice rectum. It's the line which is going to pass through the focus of the parabola, and it is going to be perpendicular to the axis of symmetry. And its endpoints are going to touch the parabola, and the length of its lattice rectum will be absolute value of 4 times a. Now in our problem, we considered x squared equals to y. That's the equation that we obtain after simplification. So here we obtain the value of a as 1 over 4. So that means the focus of the parabola, so that's 0, 1 over 4. Then the vertex will be at 0, 0. Equation of the directrix will be y equals to negative 1 over 4. Axis of symmetry, that's equation will be x equals to 0. The length of the lattice rectum will be absolute value of 4 multiplied to 1 over 4. So that means the length of the lattice rectum will be equals to 1. Now this parabola is represented in terms of the coordinate axis x, 1, y in uppercase. However, we need the coordinates of its vertex and focus, the equation of the directrix and axis of symmetry, as well as the length of the lattice rectum in terms of the whole coordinate system. That means in terms of x and y in lowercase. So here we're going to substitute this value. So let's start with the vertex. So we obtain that the vertex of the parabola is at the origin, that's 0, 0. This simply tells us that the x value is 0 and the y value is 0. However, we have to substitute the value of x with x minus 1. This will be equals to 0, and the value of y with y minus 2 equals to 0. That's going to give us the new values of x. So x will be equals to 1 and y will be equals to 2. That means the vertex of the parabola with respect to the coordinates x and y will be at 1, 2. So this is going to be the vertex of the parabola. Let us now determine the focus of the parabola. So focus of the parabola, we obtain it as 0, 1 over 4. But this is the value that corresponds to x. So x will be equals to 0 and the y value will be equals to 1 over 4. So when we substitute x with x minus 1, that's going to give us the value of little x as equals to 1. And the value of y, when we replace it with y minus 2, so we will get y will be equals to 2 added to 1 quarter. So that will be 9 over 4. So that means the coordinates of the focus will be 1, 9 over 4. This is the new focus, or you can say the shifted focus. Now coming to the equation of the axis of symmetry. So the axis of symmetry has the equation x equals to 0. So when we substitute the value of x with x minus 1, that's going to give us small x equals to 1. That's going to be the axis of symmetry. Then we have the directrix. The directrix has the equation given by y equals to negative 1 over 4. Now in place of y, we're going to replace it with y minus 2. That will be equals to negative 1 over 4. So solving this, we're going to get y equals to 7 over 4. That's going to be the equation of the directrix. However, we don't have to worry about the length of the lattice rectum because that's going to stay fixed at value 1. So the length of the lattice rectum, that's going to stay as 1 unit. The reason behind this is what we have done in our problems, we have shifted our parabola from 0,0 vertex to 1,2. We have also shifted the focus, but the length of the lattice rectum remains the same because the shape of the parabola is going to stay as it is.